Hi grade 11s, so glad that you could join me today. We are going to be looking at trigonometry in what I call trigonometry part 1. There are many parts to trig, of course. There's a huge section in paper 1 and it certainly will be a huge section again in grade 12. So in part 1, what are we looking at? We're looking at things like identities, reduction formula, and trig equations and trig graphs. That all falls under part 1. And then the next part of trig is all about spatial concepts, where we look at 2D trigonometry. So that will be for the next time. So for now, what we're going to do is we're going to start just reminding ourselves about the reduction formula. So remember, with the reduction formulae, it's all about reducing angles to simpler forms so that you can easily work with them. Okay, so we don't want to work with big angles, 400, 500, etc. We want them to be small and manageable. So some of the things we need to remember, we've got all the different quadrants, and obviously you can see what I've listed on the screen. We've got where sine of 180 degrees minus theta would give us sine theta, for example. And tan of 360 minus theta is negative tan theta. So for all of these, the big thing, and that should be a straight line. That's as straight as it can be. So the big thing is using the cast diagram. All stations to Cape Town. Okay, and what that tells me is that all angles in the first quadrant are positive, and they are also all what we call cofunctions. So in grade 11, what you need to remember for your syllabus is just the sine cofunction and the cosine cofunction. So sine of 90 degrees minus theta is the same value as cos theta, and cos of 90 minus theta is the same value as sine theta. So if you're looking at sine of 90 minus and you're trying to remember what it is, all you do is you add a CO, and if there is a CO, you take it away, and that gives you sine theta. So what that means is, if you're looking in the first quadrant, sine of 60 degrees will have the same answer as cos of 30 degrees. You can do it on your calculator and check for yourself. Sine of 60 is 0.86, cos of 30 is also 0.86. So they get the same value when they are co-ratios in that first quadrant. They will have the same values as each other. Okay. So all your angles in that first quadrant are positive, and all angles are acute, less than 90 degrees. Then between, we're going from 90 now to 180, we get all angles in the second quadrant being less than 180 degrees. So these are what we call obtuse angles. And in the third quadrant, all our angles are between 180 and 270. So these are what we call reflex angles, and only tan is positive in the third quadrant. In the second quadrant, only sine is positive, so that means all your other trig ratios will be negative. And in the fourth quadrant, we're looking at 360 minus theta, and that's where cos has positive values, and those are your values between 270 and 360 degrees. If we start going into the first quadrant again and going 360 plus theta, the same pattern repeats again. All angles 360 plus theta are in the first quadrant, so therefore they will all be positive. So you can have a look here. Sine of 360 plus theta is sine theta, cos of 360 plus theta is cos theta, and tan of 360 plus theta is theta, where theta is an acute angle. Those all end up back in the first quadrant. Okay, so that's a big thing that you use in grade 11, this cast diagram and these reduction formulae. So let's have a look at an example, because that's really what it's all about. And when we start looking at examples of reduction formula, yes, we can just use theta and alpha and beta in our reduction formula questions, but often what we do in exams and tests is we include the special angles. Special angles being 30, 45, 60, and 90. So 30 degrees, 45 degrees, and 60 degrees. Those are the main ones. We're not going to look at 90 for now. So in general, most of your angles can be rewritten with special angles in this type of question. Okay, so it really just depends on the question, but in this type of question, most of your angles can be rewritten as special angles, which means often your question will say without a calculator. If it says without a calculator, you are not allowed to use a calculator to get to the answer, because the examiner can tell. Tan of 225 degrees we can rewrite as tan of 180 degrees plus 45 degrees. Okay, and please forgive me if I get a little bit sloppy and leave those degrees out, and understand that they are there, like the 300 is missing its degree sign. We take it that it is there. Minus sine squared 300 degrees is the same as, we can rewrite it as 360 minus 60 degrees. Okay, and if you do that subtraction, 360 minus 60 does give me 300. And at the bottom, we've got cos of 90 plus 30. So that is now where we use our co-function. So cos of 90 plus 30, we leave out the CO, so it's sine of 30 degrees. But a very big thing here is this is going to be negative. How do I know that? Well, if you look at an example where we've got cos of 90 plus, now remember 90 plus is no longer in the first quadrant. You've now moved into the second quadrant. And in the second quadrant, only ratios of sine are positive. So since I've started here with cos of 90 plus, I know that cos is negative in that second quadrant. So therefore, I take on the negative when I do the reduction. So instead of this being positive sine 30 degrees, it becomes negative sine 30, because initially I started with a cos. If I started with a sine, then this would be a positive cos 30 because, so say my example was sine 90 plus theta, then my answer will be positive cos theta because I take it from the first, what's been given to me. And sine is positive in the second quadrant, so therefore cos would be a positive answer. All right, let's do a quick reduction and use our special angles. Tan of 180 plus 45, that's in the third quadrant where tan, so the first thing we do is we identify which quadrant is 180 plus in. We see that that's in the third quadrant where tan is positive, so my answer would be positive tan 45 degrees minus sine squared 360 minus 60 is in the fourth quadrant, so sine would be negative there, so it's going to be negative sine 60 squared. Even though we are squaring, we will end up with a positive answer. I still like to put the negative in just so that I don't make mistakes in other questions. Divided by negative sine of 30. Okay, and now you're simply going to put in your special angles. So tan of 45 is 1. Hang on, we're still busy here. So we've got 1 minus negative sine of 60 is root 3 over 2. You can check that on your calculator, but really what you should be using is either your special angle triangles or your diagram with special angles, all right? Sine of 60 is root 3 over 2, and we're going to square that, all over sine of 30, which is a half. Okay, and let's just get a little bit of space here. We'll put it on the little side there. Let's use a different color. So we've got 1 minus root 3 over 2 squared. Negative squared is going to be a positive. Root 3 squared is just 3 because it's root 3 times root 3. 2 squared is just 4. And that's over negative a half. All right. 1 minus 3 quarters is a quarter. And that's divided by, so we tips and times. So we tips and times, remember because we're dividing by a fraction, so we invert that, so it becomes 2 over 1. And I get, my answer is negative a half. All right. Okay, guys, and what you can do as a quick check, enter that whole fraction into your calculator and see what you get as a quick check to see that your answer is actually correct. You can do that in an exam, just a quick check, but don't do the whole sum with a calculator if the question specifically says without a calculator. All right. Okay, let's move on to general solutions. Now, general solution is really all about finding a value in an equation where you will always get the same answers for x. okay, or not the same answers for x, you will get the same y value and different values for x. Okay, so what am I talking about? Say we've got this graph, sine of x, that's drawn, okay, and I'm looking for where the y value is equal to a half. So say my question said, where is sine of alpha equal to a half? Depending on what your domain is, you can get an infinite number of answers because this pattern that's called a wavelength, it just will repeat forever and forever. Generally, we ask you to draw in a certain domain that's quite reasonable. So we might say, okay, draw this graph from 0 to 360 degrees. So yes, you're drawing it in this short little interval, but in reality, these intervals are infinite. Okay, so they're not given to you in these nice 0 to 360 or minus 90 to 90 workable patterns. They can be infinite. All right, so I want to know, well, where does this happen? A half. Where is the sine graph going to be equal to a half? And you can see that a half on the y-axis corresponds to a number of different, and in fact, let's use red here, corresponds to a number of different x values. So the y value of a half, we can see, will give us a whole lot of different answers on the x-axis. So here, 30 degrees, sine of 30 is a half, sine of 150 is a half, sine of 390, and so on and so on. And you can keep checking these for yourself. You will see that any 30-degree interval here will give me an answer, either 180 minus 30s or 180 plus 30 or 360 minus 30. Any of those kind of intervals are going to give me a value of a half on the sine graph. So really with general solutions, we try and narrow this down and we say, okay, well, we're going to take care of that infinite number of possibilities by finding a reference angle. So we get alpha is equal to 30 degrees plus k times 360. 360 being the period of the graph, because this sine graph repeats its little pattern every 360 degrees. Okay, and we say k is an element of integers. So the reason we do this, and then for sine, you also, I'm going to show you a different method, but you'd also get 150 degrees plus k times 360 or 360 times k. It doesn't matter which one you put first, the 360 or the k. You will get either of these to be the general solution, which means that these two take care of all the amount of times that this graph will have a value of a half. Infinite number of times. These two equations, this general solutions, these two will take care of all of those infinite possibilities. Let's take a quick break. When we come back, we'll look at an example and we'll talk more about general solutions. We're back after this. Hi again, guys. So today we are looking at trigonometry. We're looking at some of the big sections that you cover in grade 11. Before this break, we were looking at general solutions, and I want to talk more about general solutions. So generally, you are taught that when you're looking at a general solution, you will find out where the ratio is either positive or negative, and then find your reference angle based on that. So let's look at what I'm talking about and put an example to it so it makes more sense. So we use the different quadrants method, or we can use the following. So you are perfectly welcome to use your method, whatever you prefer. I'm going to show you an alternate method for finding the general solution, or just writing the answer of the general solution. So say we have sine of theta. We used a half before this, is equal to a half. Now to find the general solution, this first one is still the same. You will say, okay, well, because I'm looking for where sine theta is positive a half, you would say, okay, I'll get my reference angle. My reference angle will be 30 degrees, and I see I'm looking for where sine is positive, so it's in the first and the second. So my answers are going to be 30 plus k times 360. Okay, I know some of you prefer to write 360 times k. Please do it that way if you prefer. Or 150 plus 360 times k, where k is an element of integers throughout the rest of the lesson. So therefore, we look at where is sine positive, and then we find our general solutions. An alternate to that, right? That's perfectly acceptable. But an alternate to that is you can just find, it doesn't matter if we've got a negative or a positive here, but all you would do, say we had negative a half or positive a half, is you'd find your reference angle, and then your general solution will be theta is equal to the reference angle plus k times 360, or it's 180 minus the reference angle plus k times 360. So this is slightly different, this method, to looking for where, in which quadrant the ratio is positive and negative. So this is just an alternate. Please, if you do not understand this method, stick with the one where you find out where the ratio is positive or negative. So in my case, what would happen is if I'm using this method where I'm saying, okay, if I've got sine theta is equal to negative a half, my reference angle, I would just put that negative a half into the calculator, and I'd get that shift sine of negative a half will give me negative 30. So my answers here will be theta is equal to negative 30 degrees plus k times 360, or theta is equal to 180 minus 30, so that becomes 180 plus 30, which is 210 degrees plus k times 360. K is an element of integers. That would be my general solutions, and those are correct. So this is an alternate. If you were doing the other method, what you would do is you would look for where sine is negative, and you'd say that's in the third and the fourth, and you'd get 210 and 330 as your general solution. So this is really just for those of you who would like to learn something new. So for cos theta, yes, you can use that quadrant method again, or what you can do is you can say, well, cos of theta, our general solution is just theta is equal to plus or minus the reference angle plus k 360, and you will get the same answers repeating and repeating, so we don't have to do another separate equation. So for example, if I have cos theta is equal to negative a half, then my answer is going to be theta is equal to plus or minus 60 degrees plus k times 360, k an element of integers. Okay. Now tan theta is an interesting one. Because the period of tan is 180 degrees, the general solution includes integer multiples of 180. So therefore what it means is it's also possible to generate the general solution from only one angle. So I know you are often taught you will find out where is tan positive, where is tan negative, and give two answers. It is really, guys, it is not necessary. You can just give one general solution, and because these involve integer multiples of 180 degrees, all your answers can be worked out from one general solution for tan. So let's just remind ourselves what a tan graph looks like. We've got that, you've got your asymptote, you've got that, you've got your asymptote, and then you've got that. All right. So if I had, for example, x is equal to 30 degrees plus k times 180, and you were looking for where tan is positive, then your other answer is going to be 180 plus 30, which is 210 degrees plus k times 180. So what I'm saying to you, you only need one general solution, because 210 is basically 30 degrees plus, if k is equal to 1, 180 plus 30 gives me 210. So this one is taken care of. You don't need to have two separate solutions for your general solution for tan. So the simplest general solution is theta is equal to your reference angle, whatever it might be, plus k times 180 degrees, still k an element of integers. So for tan, you really just need that one general solution. Okay, and guys, these are just alternates. In exams and tests, you will be marked on the other method if you do use it. It's perfectly acceptable where you moved into the different quadrants, but for tan, please stick to the fact that tan only needs the basic general solution, which is just your reference angle plus k times 180. All right. Okay, so I want to quickly look at a question, an example of general solutions, and I want to just go through, because the main thing that learners will battle with here is how to get from the given information to a form where I can actually solve for x. So you'll be given something like, determine the general solution of 2 cos squared x minus 3 cos x is equal to 2. And this is where the biggest problem starts for most learners, because we don't know what to do. How do I get from this to a point where I can even solve for x? So the first thing we do is we notice that this is called a quadratic equation because we've got a square there. All right, do you see the ratio of the first two terms? 2:1. Therefore, this is a quadratic trinomial. For those of you who cannot see that this is a quadratic trinomial, what I urge you to do, and this will really make your life a lot easier if you are getting stuck in exams, let cos x equal to k. And then you'll substitute your k back in and you will get the question right. So we will get this 2k squared, because wherever there's a cos x, I'm putting a k. So I get 2k squared minus 3k minus 2 is equal to 0. Now, guys, you can hopefully all clearly see that that is a quadratic trinomial. So all I'm going to do is I'm going to factorize that using what I know about quadratic trinomials. So I'll get 2k times k. We'll have a 2 there, a minus, and a plus 1. So this is just factorizing trinomials. And from there, I'm going to get 2k plus 1 is equal to 0. K minus 2 is equal to 0. So therefore, k is equal to -1/2, or k is equal to 2. This one is going to have no solution because our cos graph only goes to 1/2. Remember, k was actually cos x, so we put cos x back in, and look at that. We've avoided using trig trinomials. We've gone straight into algebra and then back to trig. Okay, so for those of you who cannot see these trinomials, please use k. You do not get marked down because you've tried to make the question simpler for yourself. In fact, you will get more marks because hopefully you'll get it right by using a substitution. All right. If you can see the trinomial straight away, you are welcome to do what I've done here, which is just factorize into your quadratic trinomial using the ratios of cos. So we get 2 cos x plus 1, cos x minus 2, and just as you saw with the k's, cos x is equal to -1/2 or 2, this one being not applicable. And therefore what we would do using the method that I used, not using the method of working in the different quadrants, which will give you different answers, but using the method I use, I would simply say second function cos of -1/2, and I would get 120. In fact, that just reminds me now, looking at that, when I did an example here, this -1/2, my answer wasn't going to be 60, it was actually going to be 120. Okay, so if we go back to this one, you get that x is equal to plus or minus 120 degrees. You simply put that -1/2 into your calculator, plus k times 360. K is an element of integers, and that is your general solution. And in fact, I just want to go to our calculator and show you if we go shift. For some reason, my calculator is not working. Shift cos. All right. Our calculator doesn't want to work, but that's fine. We understand that if on our calculator we go shift or second function cos of -1/2, we will get an answer of 120 degrees or -120. And then we add in plus k 360 to show that this interval repeats infinitely. Okay. Okay, guys, so I would love to talk to you about identities and so many other things, but this is all we have time to do, and I hope that this general solution method that I've given you, this alternate method, is going to make trig general solutions a lot easier for you in exams. And remember, if there's any type of new method that you're really struggling with, all it takes is just a little bit of practice to become perfect. Until next time, take care. We'll be back next time. Cheers.